when we have a tabular data and give a simple text box to ask question, the user has a lot of expectation. This is because this is free form. You can ask anything, right? And the data might be not available. So there's a lot of challenges to kind of how we ask and what we expect. And this model is in pretty good shape.
Hello and welcome to the AI Master Group podcast, featuring the people who are building the future of AI in their work today. I'm your host, Jim Griffin. Today, I am very happy to have as my guest Iqbal Hossain, who is the Director of Research Data Science at the University of Arizona, just down the street from me. He's also been connected in the past to universities in Bangladesh and in Italy. Iqbal has got a PhD in computer science and engineering from the Bangladesh University of Engineering and Technology. Welcome, Iqbal.
Thank you, Jim. Thank you for having me.
I'm really glad to have this opportunity, Iqbal, because I know that you've had an amazing and actually very inspiring personal journey to where you are today. Can you share some of the details about that?
Sure. So I grew up in a very rural area of Bangladesh. The interesting thing is there was no water, no electricity, no paved road. So you can imagine that I had to overcome a lot of challenges to be here. All of the things happened just because of my hard work and dedication. So let me tell you a little bit more about how my typical childhood day looked like. So I used to go to school with my shoe in my hand. So can you imagine that why someone can go school with shoe in the hand? Because there is no paved road and it's a whole lot of mud. You don't want to mess up your shoe to go to school. So I used to take my shoe, walk a mile or two to go to school and wash my feet and hand and put the shoe back and start school. So, and then in the afternoon, I had to take care of the cows because my whole family is from a farmer family. So it was very painful job to process and cut by hand all the straw and make it small pieces so that the cows, they can eat it. And it was very dangerous job because if you lose your focus, then immediately you cut your hand. And that's why I got a lot of cut in my hand. So that's the afternoon. But in the evening, there was no electricity. So what we used to do with me and my siblings, we used to burn kerosene oil to make the flame. And under the flame, we used to study book. And the flame, I don't know if you have experience on this using this flame or not, but this is very a little much flame, and you can put your book and you can do study. And the first time I touched the electric switch when I was 11th grade. So that time I actually get touched to wall electric switch that make the light. So there are many stories like that in my early childhood. And then I got very lucky to get chance in engineering university at Bangladesh. And I got chance to study computer science. That was very demanding and very competitive to get that chance. And after graduation, I started my job as a computer programmer, and then I was promoted as a senior programmer, then I was promoted as a system analyst. Then I realized that hey, I can do much more complex work. So what can I do? So why don't I do my master's and PhD in computer science? So that's triggered me that I can do much more complex job. And then I got admission in PhD, master's and PhD, and did my PhD in computer algorithm and graph theory. So that's one of the very difficult part in computer science, to work with the computer algorithms. And then finally, I came here at the University of Arizona as a postdoc researcher and started the knowledge map project you have seen. So that is my kind of a very high-level story, how I got there.
That is amazing. You're right. Graph theory is at another level to what most people think of when they're talking about computer programming. And that, of course, intersects with the knowledge map that you've described, which I've seen. It's a very interesting project you're, of course, doing for the University of Arizona. Can you unpack for me a little bit more about the brief that you were working on when you were creating that and why that's important?
Mm-hmm. Sure. So what is knowledge map for higher education industry or higher education institute? In higher education institute, there are a lot of researchers and there's a lot of research happening. So what my team does, collects varieties type of research related metadata that includes publication, proposal, patents, grants, CV, biodata, coursework, all kind of unstructured data we collect from many sources and analyze them and create a user interface so that the user can interact with this complex information. We have created an interesting way to visualize this information that we call map. So basically, we extract information to build the collaboration network of our whole university. And we embed that graph into 2D plane and create a cluster by department, and bring in as an interface so that user can actually zoom in, zoom out, and each of the polygon is a department, and when you zoom in, zoom out, the most important people show up. And if you click somebody, then you can see that this person collaborates with whom and why this collaboration. You can search people. You can kind of explore the university's knowledge landscapes. So that's why the name comes, the knowledge map. This is very interesting project because this project actually intersects many things in computer science, data science, and software development area. We have many 10, 15 different sources that we collect the data and then process that data. And it is an intersection of information visualization, machine learning, artificial intelligence, and then software development. Because when you see the interaction or the user interface, then you see that this is very responsive and this is very interactive. So, and you ask why this is important. So, this system is giving a way to collect varieties type of research metadata, and that are normally those are the things sittings across the university in many different departments, many different unit manages those. And currently there's no good way that collecting all the data and use that data. So that's why this project focusing collecting all this piece of the data and bring in one place as a university's research focused research system. And then the universities are big, large. So many researchers are coming and going, right? It is changing. It's very difficult to keep track all of the changes, all of the research expertise and inventory of the university. So that's why I need an automatic system, so that if somebody comes at the university, and people should be able to find them. When the university or some researcher need to create create a big project, they need to find who is the expert at the university. They need to find the people. When a student wants to collaborate or wants to do their career in some specific area, they need to find the relevant people, relevant researcher or labs. So if we don't use that data and bring in one place, then it's very difficult to actually serve this purpose. So that's why I think that every university need to build this kind of system, so that the faculty member, researcher, students, and administrator understand the research impact of the university. So that's why they're important.
One of the things that kind of is implied in what you said just now, but I think I would make it explicit, is that it seems to me like what you've built was built from the ground up, from scratch. It doesn't look like you plugged in something and then just modified it. It was really made from scratch. And that's a big project. So I'm wondering, just from a management standpoint, how did you organize your efforts and create a roadmap and timelines and priorities for such a big project? Maybe you didn't even know all the parts of the project when you first imagined it.
Yeah, definitely. Yeah, this is interesting because right now in knowledge map we have many feature, many data, but we did not start it like that. So when I came here at the University of Arizona, my professor gave me a kind of a half-page a description that, hey, this is your project. So what is basically in that document is one line written: find who is working on what at the university. That's the fundamental question. I was thinking, oh, that is easy because, how difficult it could be. But slowly I realized that this is much more complex project to understand who is working on what with the large scale university. So I started from there, and slowly it is growing. So during this journey, so this is a long answer, but I will highlight a couple of key points here. One is define clear objective. That's I try to do that, why I am doing this and what are the stakeholders. That helps me to keep my focus in the right way. And then set up the use cases, why we are building this part, why we are designing this part. So that the use case helps us to guide those things. And then we use agile methodology to deliver this project. So what it is kind of iterative development. So look one improvement of the project, understand it, and develop it, and then deploy it, and then getting the actual feedback from the user that are they liking, is there serving purpose. So we in this process we are continuously talking with the user, and our user is actually a student, faculty member, researcher, administrator. So this ecosystem helps us to actually create a kind of clean timeline and a sprint that in these 2 months we want to do this and we want to deploy this part. That helps me a lot to keep the project roadmap implementable.
I see. So you're actually doing it in sprints. Okay. Another thing that's unique about your project, aside from the graph theory aspect, is that when we think about Gen AI, most people start with unstructured data, but you're working, in your case, I think, with a fair amount of structured data as well in the form of tables. So I'm wondering, what's been your experience so far in regard to that aspect and that context for Gen AI?
Yes. So Gen AI, if you think about data perspective, then two broader type of things. One is generative AI with unstructured data. Another part is you have structured data and you have some question. You have unstructured data, you have some question. You have structured data, you have some question. Now, the interesting part, even the name is very similar, but it works very differently. For structured data, you may have many tables kind of data. You have fixed row, column, and very specific data type, and not much more text data, but also number and category, those kind of data. Now you have question. So in last couple of months, we are developing the RAG model for structural data. And what is this data? This data about the university's student census data. So that's basically all the facts and number and the other things happening at the university, different statistics, different record, historical thing is coming as many tables data, and we are building a system so that you can go and ask a question. For example, you can ask the question, what was the retention rate in last year? Or how many international students got admitted at the University of Arizona this year? This kind of factual thing you can ask in this model. The experience, this is very interesting. The way it works is it actually a chain of command or chain of interaction with large language model. The first step is there's three major steps. The first step is when you ask question, it identifies what you are asking. Where is the data? Okay. And then second step is you identify data, you have the question. What is the numerical answer or statistical answer that you need to compute from the data? So you ask, what is the average SAT score, the student who got admitted at the University of Arizona, right? So that means there is some calculation required behind the scene. So the second step, actually, you have data, metadata, you have data, and you have question. On fly, you want to generate some code to compute that result for the question.
You're listening to the AI Master Group podcast.
You want to generate some code to compute that result for the question. That's the second step. The third step, so you have the data, computed data, and the question, and you want to give the response in human language. So it goes again to large language model. Hey, I have this data, and somebody asking this question, and what is the result, right? So all the structural RAG system has kind of three or more different type of interaction with large language model to find the answer and show the answer in the interface. So we have deployed a test version to see the impact or what people are asking and storing feedback and understanding the model response. We are doing that. The challenging part is this: when we have a tabular data and give a simple text box to ask question, the user has a lot of expectation. This is because this is free form. You can ask anything, right? And the data might be not available, right? And sometimes you are asking that how many students at the university? The question in the behind the scene, you need to tackle that they are asking the not historical question. They are asking that how many students got admitted in 2022, right? But they're not asking the date, right? So there's a lot of challenges to kind of how we ask and what we expect, right? So we are handling those challenges here, and this model is in pretty good shape. Yeah, I hope sometimes I will show you.
Like to see that. It's very interesting. You're talking about keeping track of these things and so forth. One of the questions that was in the back of my mind as you were talking about that, maybe we should talk about it, is the infrastructure aspect. So you could be doing this in the cloud. You might be doing it on private servers. What did you decide to do, and what was the reason for that?
Yes, this is interesting question and big question, because many university and many organizations trying to figure it out this. There are a couple of very key things to take decision. One is cost, data privacy, and how do you manage this infrastructure, a deployment environment. There's a lot of things here. So at the University of Arizona, we are starting. The way we are planning is to create a kind of a complete isolated infrastructure for AI-based system. What that is, it starts with data governance. So from the warehouse, that we're gonna do the data governance and bring the data for specific use cases into AI infrastructure. So in the AI infrastructure, it needs to do many different things. It is not straightforward. So now question is, should we do in private infrastructure or you need to go cloud? So if you think about the cost, then it's look like a purchasing car or you want to rent a car, right? If you look about data privacy, definitely you need to launch this and maintain this system in your private space, private infrastructure. You don't want to create a kind of send data to public API. There are some challenges on creating private infrastructure. I think I would say big challenges, because it is very hard to develop this kind of ecosystem, because it needs data pre-processing, it needs creating vector database, it needs to have a semantic search environment so that you can find the relevant document. You need a way to get the identify the result and document, and then you need to do prompt engineering, you need to do fine-tuning large language model, you need to evaluate. So all of the things are related if you want to launch this kind of system in private infrastructure. And this is hard to maintain, because it needs a lot of skill and expertise to do that. So to answer your question, there is no straightforward answer that we can say, hey, go for cloud, go for, or build your public private infrastructure.
But what did you do?
So we are creating Amazon. We are using Amazon Web Services, and we're creating the new infrastructure so that we can do at the university by ourselves. You can think about we are launching all of the system in our private infrastructure.
Interesting. So I'm interested in this because another question that's in the back of my mind is, I wonder if another university or enterprise wanted to do something similar. Do you think, given this private infrastructure cloud question, do you think there might be a way for them to leverage the work that you've done?
Yeah, definitely. There's a two main part here, right? One is infrastructure related. That definitely every university would want to go for private infrastructure so that they have all the control, they have all the security privacy thing. That's one thing, the infrastructure question. And there's another big part is all data code and implementation of software layer. And for software layer, we can help, we can collaborate with that university. In fact, we have been asked from multiple universities, they want to create a knowledge map kind of system for their university. And for infrastructure, I would say every university, they should have their own infrastructure.
I see. If every university does this in their own silo, there's ultimately going to be a desire to see this information across all the universities in a particular geography. And finally, across all the universities around the world. That's something that ultimately would be the big prize to do that. Do you have any thoughts about what that might look like?
Well, we need to solve the data governance and data security, privacy, all of the thing first. Otherwise, we cannot do everything in one common giant places. That's my thought. Because the AI data governance is different than the regular data governance. And all of the AI model comes with a lot of other challenges like data privacy thing, everything. So from my experience, I would say there are a lot of challenges. It's not only multiple university, but also use cases, right? So you have different use cases and it needs to treat differently. It's not like you put all the data, your infrastructure ready and ready to go. Because when you work with the sensitive data, you need to handle differently. We need to look if we are feeding some data and the model is biased or not, or the model is learning something that is somebody's private data, right? So it's not a straightforward that like, hey, create a shared web server kind of thing and put your website, multiple people can launch their own website. It's not like that is straightforward. So I think the question you ask in the down the road, probably from many years from now, I can see that sometimes it will be getting a central kind of services so that everybody can have put their data with supports all the use cases. But right now, I think this is kind of every university should figure it out, their own use cases, priorities, and build the AI solution for them.
Walk before you run. Okay, so, and in regard to use cases, I think that, of course, in fairness, we've been focused on this very exciting project that you've been working on, which is this knowledge map. But are there any other projects that you've been doing over there?
So the knowledge map project itself is a big project, and we are creating more layer and more focus within the project. So one of the focus is rack system for unstructured data. So you have seen the knowledge map is kind of, it gives the interaction, it gives the search capabilities, but can we ask question about universities' facilities, universities' research opportunities, or can I ask a question about grants, right? Can I ask question like, who is the expert at the university on some specific area, let's say information security, right? So can we ask this question? Can we get that answer? So we are using all of that data, we are creating the unstructured rack system for the university's student, faculty member, and external people so that they can ask questions. For example, an international student has dreamed to do their research on networking or cancer research, right? Then can they go in a system and ask that, who are the expert at this university with cancer research? So we are developing that part in kmap, so that the student and the other university administrator can ask those questions.
Nice. And I also remember you're showing me something that I thought was pretty interesting, and correct me if I'm remembering this wrong, correct my understanding about what you built there, but it was something like this. Somebody in marketing at the university just wants to know what it is that's happened in the last 24 to 48 hours that's important, of all the different things that were published or announcements that were made. Roll that all up, let them know what that is, and even suggest to them what the text might be for the announcement, something like that. Can you fill in the parts that I got wrong?
No, you were right. So the university, they want to publish the news very quickly, important news. So one of the extension of the knowledge map we have is we have grant metadata. So that includes the grants, abstract, title, and funding agency, faculty profile, there is PI, co-PI, biodata. So use all of those things are grant metadata. Now, we are creating a custom prompt engineering on top of this data so that, hey, you can ask hey, what might be the outcome of this project in plain English language, right? And that is super helpful for the news writer because they don't need to know all the details about some astronomy project, right? This is very hard to understand, and nobody are expert in all different areas, so they need some simplified language. And so we create a kind of interface so that they can go and they can ask that, what is the main focus of this researcher? And they can get the immediate text, and they can read it, they can modify it, and they can use this text in their news writing. So that we call AI assist news writing tool. We deployed that tool at the University of Arizona.
That seems very interesting. And that may have applications outside of even just a university setting. All the universities, of course, it would be very relevant, but even outside of a university, there are places like GE labs and other places where there's all kinds of stuff going on in there that not one person would fully understand. So very interesting. Well, this has been extremely enlightening, as I expected it would be because I know you, and I imagine that some listeners might want to follow up on some of this, maybe even see what you've built. If so, how can people best get in touch with you?
Well, if someone wants to look the project we are talking, so they can visit kmap.arizona.edu. That's the project we launched, and then I can be reached in LinkedIn.
All right. Perfect. Well, Iqbal, once again, thank you very much for sharing this time with me. I really learned a lot. I'm going to have to go back and study what you said. Some parts of that are worth looking at twice. So again, thank you very much for joining us on the show today.
Thank you so much to give an opportunity to talk with you.
You've been listening to the AI Master Group podcast. I'm your host, Jim Griffin. Until next time, stay curious and stay in front.